Zeroth law of thermodynamics. I will tell you why we call it zeroth law. So because we never heard about something zeroth. Like always we start from first, second, third, fourth. So first time you are hearing zeroth. Okay, so I will tell you why it is called as zeroth law of thermodynamics. Okay. So I will take three systems. System A, system B, and system C. Okay, first system A and B, there is insulated wall. What is insulated wall? I have already told you. Insulated wall means from that wall there will be no heat transfer. From their wall, no heat transfer will take place. So that is called as insulated wall or adiabatic wall. Okay, so between A and B there is an insulated wall. That means from A to B or B to A there will be no heat transfer. Okay, and we have third system C. So between A and C and between B and C there is no thermal insulation. There is no insulated wall. Both are directly in contact. Okay. Now what will happen? What will happen? A and C, B and C. Between A and C and B and C, wait a minute. Between A and C and B and C, some heat transfer will take place. Because A and C are in contact, B and C are in contact. A and B are not in contact. Okay. So macroscopic variable of A and B will change until A and B will be in equilibrium with C. Just please pay attention here. A and C are in contact, B and C are in contact. A and C, B and C. These two are in contact. So A and C are in contact, B and C are in contact. That means macroscopic properties of A and B will change until A and B both are in equilibrium with C. See, we have already seen when two bodies are in contact, their macroscopic properties, or we can say their temperature, will change until their temperature will become equal. And when their temperature will become equal, we can say both are in thermal equilibrium. So we can say there is some temperature of system A, TA, there is some temperature of system B, TB, and there is some temperature of system C, TC. Okay, A and C are in contact, B and C are in contact. So after some time, what will happen? A and C will be in thermal equilibrium. B and C will be in thermal equilibrium. Okay, after some time, what will happen? A and C will be in thermal equilibrium and B and C will be in thermal equilibrium. So what will happen in thermal equilibrium? What will happen in thermal equilibrium? The temperature will become same. Okay, for now we will not talk about temperature. Just understand, after some time what will happen? Their macroscopic properties will become stable or will not change with the time. Okay, so when their macroscopic properties will not change with the time, that means A and C will be in thermal equilibrium and B and C will be in thermal equilibrium. Okay. Now I'm just telling you like what is given in NCERT. Directly I can tell you, directly you will understand, but what is given in NCERT, okay, I'm trying to explain that. So when A and C are in contact and B and C are in contact, so after some time what will happen? Their macroscopic state will not change and when their macroscopic state will not change, that means we can say A and C are in thermal equilibrium and B and C are in thermal equilibrium. Yeah, wait. Wait, I will tell you. Both will be in equilibrium. A and B also will be in equilibrium. But I'm trying to show you something. Now what we will do, we will replace that insulated wall between A and B with conducting wall. With a conducting wall. Conducting wall. That means we can say there will be heat transfer from A to B. There can be. Okay. And here between here we have inserted an insulated wall. Now try to understand what will happen. Will there be any change in the macroscopic property of A and B? क्या कोई चेंज होगा इनकी मैक्रोस्कोपिक प्रॉपर्टीज में, A and B की प्रॉपर्टीज में? Already we have seen A and C are in thermal equilibrium, B and C are in thermal equilibrium. Okay. Now we have disconnected C with A and B, and we have connected A and B. Okay. Earlier there was insulated wall between A and B, but now we have replaced that insulated wall with a conducting wall. And here A and C and B and C are in contact directly, but here we have put an insulated wall between A and C and B and C. But we have already seen when A and C are in equilibrium, B and C are equilibrium. That means their macroscopic properties will not change with time, and their macroscopic properties will not change with time. So what will happen? A and B are in contact, so their macroscopic properties will also not change. That means we can directly say A and B are also in thermal equilibrium. A and B are also in thermal equilibrium because their state will not change. State means their temperature, their pressure, these things will not change. So from this experiment, we can formulate our zeroth law. From this experiment, we can formulate our zeroth law, and that how? If A and C are in equilibrium, are in thermal equilibrium, and A and B are in thermal equilibrium, then A and B will also be in thermal equilibrium. It was so much obvious. Okay, like you can say, sir, इसमें क्या था? ये तो बहुत आसान सी चीज थी ना. There was something, there was nothing new here. अगर A and C are in thermal equilibrium, B and C are in thermal equilibrium, directly we can say A and B will be in thermal equilibrium. But it is not so much obvious. Like you can say there are three persons, A, B and C. If A and C are friend and B and C are friend, so it is not necessary that A and B are also friend. So it is not that much obvious. Okay. So it is not necessary that A and B will also be friend. So if you will see that in general, like A and C are in thermal equilibrium, B and C are in thermal equilibrium, so it should be A and B also will be in thermal equilibrium, but it is not that much obvious if you will see it in general. Okay, in thermodynamics, it is obvious. Like if temperature of A and C is same, temperature of B and C is same, then we can say temperature of A and B will be same. Okay, understood? So from here we can conclude. If temperature of A is equal to temperature of C, because A and C are in thermal equilibrium, and temperature of A is equals to temperature of B, because A and B are in thermal equilibrium. So simply we can say that temperature of, sorry, that is B and that is C. Wait a minute, there's a mistake. Here it should be B and C. So if TA is equals to TC and TB equal to TC, so simply we can say TA equal to TB. System A and system B both will be in equilibrium. Okay, so I hope all of you understood this thermal, that is Zeroth law of thermodynamics. How many lectures you finished this chapter, sir? Today only we have taken only two topics, no? Thermal equilibrium and Zeroth law of thermodynamics. One by one, we will cover all the topics of thermodynamics. Okay, tomorrow we will cover first law of thermodynamics, heat, internal energy. These topics we will cover tomorrow. Okay, so temperature A of is equal to temperature of B. That means system A and system B both are in thermal equilibrium. So what is the application? What is the application of Zeroth law? Thermometer. Thermometer. What is thermometer? Thermometer is an instrument or a device which measures temperature. Okay, so thermometer works on what? The Zeroth law of thermodynamics. So thermometer works on Zeroth law of thermodynamics. How? So if you will see, thermometer is like there will be a fluid. Mostly that fluid is mercury, and there will be this type of like bulb. So how it works? This thermometer, how it works? There will be a scale, some numbering, some scale will be there on the thermometer, and what will happen? How it works with the Zeroth law of thermodynamics? Let's see. If you will see, when you will put that thermometer in your mouth, then this surface is in contact with your mouth. This surface is in contact with your mouth. Now what will happen? Your tongue and this front part of this thermometer will be in thermal equilibrium after some time. That's why we put the thermometer for some time, so that those two objects will be like your tongue and that front part of this thermometer will be in thermal equilibrium. Now what will happen? That part is in contact with that fluid which is filled in this thermometer. Now what will happen? This part and this fluid will become in thermal equilibrium. How? This, after getting some heat from your tongue or from your mouth, that fluid will start to expand. So it will expand, and when it will expand, its temperature, that fluid's temperature and this front part's temperature will be same. So if you will call yourself as A, and this front part as B, and this fluid inside this thermometer as C. So how it works on Zeroth law? Like this front part and your tongue will be in thermal equilibrium. When you will that your tongue will be in contact with this front part of the thermometer, these two will be in thermal equilibrium. So after that what will happen? Then B and C, that front part and this fluid which is filled in the thermometer, both will be in thermal equilibrium after some time. So what temperature this fluid shows, we can say that temperature is same as our body. So A and B are in thermal equilibrium, that means we can say TA equal to TB. B and C are in thermal equilibrium. That means we can say TB equal to TC. So by Zeroth law of thermodynamics, by Zeroth law of thermodynamics, we can say that TA is equals to TC or TC equal to TA. So what temperature is shown in this thermometer, that is the temperature of our body. So I hope all of you understood how thermometer works on this Zeroth law of thermodynamics. Okay. So this was Zeroth law of thermodynamics. This was the basic, we can say, like we understood how we measure the temperature, and how temperature plays a very important role in thermal equilibrium. Like if two systems are in thermal equilibrium, we can say their temperature is same. Okay, and so that's it. Those things we understood in today's lecture. And tomorrow we'll start first law of thermodynamics, heat, internal energy. Okay, so that's it. And very few questions are asked on this topic, Zeroth law and thermal equilibrium. But you should know, till now they have not asked, but in future they can ask. So you should know all these things, all these concepts. Okay, and these are basic concepts, so we will use in further chapter, in this chapter. So for today, that's it. I hope all of you understood. So please subscribe this channel and like this video and share with your friends. Thank you.